We are going to examine a number of different ways in which we can write linear equations. One form in which a linear equation can be expressed in is that of slope-intercept form, which we commonly denote as y equals mx plus b. So y and x are going to be your two different variables that you're relating together, and then the m, that's the coefficient of x, is going to denote the slope, and then b is the y-intercept. So you can see through example, if you have a linear equation like y equals 1/3 x minus 2, you can see how that's exemplified in a graph, where it's going to have a y-intercept at 0, -2, and then has the slope of 1/3 unit of rise for every 1 unit of run. So to be able to write an equation that is a linear equation for a line, and if you're going to write it specifically in slope-intercept form, thinking about the fact that in slope-intercept form, you have the slope and you have the y-intercept in the equation, those really would kind of be the two key things that you would need to write directly into slope-intercept form. So you would need to know what the slope of that line is, as well as a particular point, which would happen to be the coordinates for where the y-intercept is located at. So just a very simple example right here is what is an equation of a line that has a slope of 6 and a y-intercept at 0, -5/2. So with that then, you can simply write it in mx plus b form. So since the slope is 6, that's going to be the coefficient of x, and then since it's crossing through -5/2 as the y-intercept, then by subtracting 5/2, then that's going to give you the equation there. Very similar thing right next door right here, because you're given the slope is 3/4 or 0.75, and then you also have a y-intercept that's at 7. When you're working off of a graph, if you have a very nice integer coordinate y-intercept that you know, as well as you can definitively determine the slope from the graph, then it's easiest to just go in slope-intercept form like we've been doing just now. So the big things to find are slope and y-intercept if you can find them. And it looks like for this particular line right here, it looks like right there would be the y-intercept, which is at 5. And then we'll also want to be able to determine the slope, but it doesn't look like it has very nice integer coordinates until it gets like way down there. So if we were to find the slope, you'd have to count all of that rise, which is like 9/1. So it turns out that the slope would be 9. So the equation for this line, there we go. Y equals positive slope of 9, and then also a positive y-intercept of 5. And so that would give you the equation for that particular line. And then this middle graph right here, it's crossing through the y-axis is exactly -3, so that y-intercept is known. And then you can see that these other dots are going to be other coordinates, and so you can see that there's a rise downwards of 1 unit and then rightwards of 4, so it will have a negative slope of -1/4. So that -1/4 then could be the coefficient of x, and that -3 is the y-intercept, and that gives you that equation for that particular line. And then for the very final one right here, it's crossing through the y-axis at 0 on the y-axis there, and then for the slope of this, it looks like it's going down 2 units and then over 3, so the slope would be -2/3. You can make that the coefficient of x, and then, I mean, you can write +0, but we know that anything +0 shows itself, so really in its most simplified form, you just leave it as y equals -2/3 x.